Alright, so we're going to use the animation skills you've just learned and a lot of the other skills you learned in the previous section to make a game that I call Connect 3. It has a lot to do with a game called Tic Tac Toe, but it's kind of mixed with Connect 4. Let's see how it works. When you tap on one of the blank areas in this grid, a counter falls down from the top and it alternates between red and yellow, and the aim of the game is to get 3 in a row. So basically the same as tic-tac-toe, but you have these counters that drop in from above and the game is yellow versus red. So hopefully you get the idea. We can play as many times as we like, and then when we've got 3 in a row, that is either vertically, horizontally or diagonally, the phone will tell us who has won and give us the option to play again. So there's not much there that you haven't done before, but it's the complexity of it and putting it all together that will be the challenge. There's a link to download the image resources for the background grid and the counters in the next lecture. So go and grab those, or you can of course make or download your own if you prefer. And I'm going to give you a little hint to use the grid layout to lay out your counters. And you might want to investigate something called tags to keep track of which slots have been filled and whether they've been filled with a yellow or red counter. That's all I'm going to say for now. Of course, if you have any problems, just watch me in this video, but otherwise, pause and give it a shot. Best of luck. Alright, well, I hope that went well for you. As I said, that was a big game to make single-handedly, so if you did manage it, congratulations. If not, not to worry. Let's see, you could have done it. So, as usual, we'll start with a new project. I'll call it Connect 3 game. Usual options. We just need the one empty activity. And then we'll start by bringing in our images. So here we've got yellow, red, and board. So I'm going to copy them. You can just drag them in if you're on Windows. And then we'll put them in the drawable folder. Oh, a little bit of patience is required. Let's try that again. There we go. Great, now they're in. Okay, so let's start with our layout. Our board image that I'm using is a square, and it's divided into 9 sections, 3 by 3. So we can use a grid layout to do this for us. So I'll just bring it in. There we go. So now we've got our grid layout that I'll just add constraints for. And an ID. And we're going to need to set the number of rows and columns. So we want both of those to be 3. So we want 3 rows and 3 columns. Excellent. A couple of other settings we can change while we're here. We want it to be a square. So we've got the width as 368. I'm going to set the height to be 368 as well. Oh, and just make sure that's DPs. And I'm going to set the background image to be our board. There we go. So we've now got a grid layout with our nice board as the background, so we can start putting our counters in place. So let's add an image view. And you can see our grid layout appears here. I want this one to be top left. So I'll just put it up there. And we'll make them all red for the moment. We'll have to change them programmatically anyway. Excellent. So there's our top left. To add another one, I'm just going to copy and paste. So pop that in there. You can see it appears next to it, and we're starting to see the grid format now appearing. So add a third, and we get 3 in a row. The fourth appears on the next row, and then 5, 6, 7, 8, 9. Now we do have a few problems there though, as you can see. So let's fix those. Firstly, I'm going to set the width and height so that it fits nicely in the box. So rather than wrapping content, let's try something like 100 dps. That's not too bad actually. I think with the right margins that can work well. Speaking of which, let's set those, although I'll just set the height to match as well. So now we've got a width and height of 100 dps, and then the margin, we'll probably have to set specific margins for each one. But let's get this one positioned nicely first. We'll start off with 10, and that looks pretty good to me. I think if you wanted to be super accurate, you could do maybe a little bit better than that, but that's centered as we need to be for now. So let's redo our copy and pasting so that we get counters that appear in the right place. Okay, so vertically that one looks good, but I think we need to change the left margin to maybe 15 dps. Let's have a look. A touch more, I think. It is nice to get things as centered as possible. Great. So that one's looking good. Let's update the IDs as we go. So we'll start off with image view 1 and then 2, 3, etc. Paste in another one. I think that's good, although it looks a little bit off to the right. To me, let's experiment a little bit. Great. That'll do. And now I'm going to be bold and copy all 3 of these in one go, because I'm reasonably confident that they will display nicely. I think they definitely look good horizontally. Vertically though, I could do with bringing them down a little bit. So let's add, starting with this one, Android, layout, margin, top. And let's try 13. Yeah, I think that looks good. You can see the advantage of doing it using XML here. It's a lot quicker than it would be selecting them all and manually changing everything on the design view. Okay, almost there. Copy those 3. And the last 3, again, need to be moved down a little. Let's try 16. 16, 16. Great. And then 7, 8, and 9. Brilliant. Okay, looks good in the preview here, but I think it's now time to run our app and just make sure that everything is displayed on the device itself, or at least in the emulator, as we want it to be. All right, so we're looking good, but of course we don't actually want the board to look like this initially. We want it to be empty, and we want to drop the counters in when the user taps on one of these spaces. So let's work with this particular counter, and we'll start by just getting rid of the source completely. So the image view is still there, but it doesn't have an image displayed on it. What we want is when the user taps on this image for a counter to drop in from the top and appear or settle there at the bottom. Okay, so to do that, we're going to need to add an onClick method for this image view. We've done that before. So I'll call this drop in. And then let's go and write the code for our method. So we're used to this. Public void, doesn't return anything. Call it drop in. And it's going to be called by a view, which will be the image view that was tapped on. Now for the first time, we do actually want to access this variable this time, because we need to know which one was tapped on, as we're going to be calling the drop-in method from all of these. So what we'll do is create a variable of type image view with a name counter, and this is going to be equal to the image view that was tapped on, i.e. view. But view is a view, of course, so we need to cast that to an image view, just as we do with find view by ID. And then we want to drop the counter in, which is going to involve a few different steps. So first of all, I want to translate it outside of the screen or above the top of the screen so that it can drop in. So let's take our counter, and we could animate this, but as we did in the previous video with set X, I'm going to set translation X to minus 1000, which should take it off the top of the screen. Maybe we'll make that 1500 just to be sure. And then I'm going to set the image for it. Now we did this way back in section 1, but you may remember we take our image view and we set the image resource. And in this case, I'll use yellow just to make it look a bit different. So resources.drawable and yellow. So we've moved it off the screen. We've set the image view image to the yellow counter image, and now we're going to drop it back down again. So we'll use counter.animate, and we want to translate Y by 1000 or 1500, sorry, to bring it back down. And we'll do this pretty quickly. We'll see how it looks. We might need to adjust it, but I'll go for 1/3 of a second. See how that looks. All right. So now when we run the app, we should have a blank space, bottom middle, and when that blank space is tapped on, the yellow counter should appear from above. And just before I run that, you may have noticed a small mistake there. I want to set the translation Y because I want it to appear above the screen, not to the left of the screen. All right, let's give that a go. So now I tap on the invisible counter, and there it is. That looks great. Just a quick thought, we could even do a bit of a rotation so it spins as it comes in. That might be quite nice. Let's have a quick look. Just add a little bit of flair. Yeah, barely noticeable, but I think I'll keep that in. All right, so let's now add that to the rest of our counters. So first off, we want to get rid of all the drawable reds. What we can do there is use find and replace to do that all in one go. So I want to replace what I've selected there, and I'll replace it with the setting the onClick method to drop in, because that's another change I want to make, so I might as well do them both in one step. There we go. So now they've all got the onClick method applied, and they've all had their images removed. So let's have a quick look. We should now find that we can tap on all of those images and they will drop in from above. Here we go. Brilliant. That is looking great. Okay, a reasonable amount more to do though. Next, of course, we don't want them to be yellow every time. We want them to alternate in color so that the players can take turns. So let's make that happen. I'm going to create a simple integer called active player, which is going to be 0 for yellow and 1 for red. Now you could use a boolean here, true or false, and that would work fine, but the integer has the advantage that if you want to extend the game at some point to more than 2 players, then that's relatively easy to do. So I'm going to enable that extensibility by using integers. But I'm just going to put a quick note here to make clear that 0 is yellow and 1 is red, because there's no way that someone reading my code would know that without trying it out. All right, and then when we drop the counter in, we just need to check to see what the active player is. So if the active player is 0, then we want to bring in a yellow counter, and also we want to set the active player to 1, so that red will go next. Otherwise, the opposite is true. And we want to set the counter image to red and set the active player back to 0. All right, let's have a look. We should now get yellow and red counters alternating. Yellow, red, yellow, red, yellow, red. Excellent. Okay, so actually the game is now playable as it is. But it's not very satisfying when you get 3 in a row for the game not to point out that you've won. So this is the tricky bit, really. We need a way of keeping track of which color each image slot is and detect whether someone has got 3 in a row or not. So first off then, we need a way of keeping track of what color each counter is. And to do that, we'll need to have a way of referring to each of these bases. And as always, there are several ways to do that, but one that I'd like to introduce you to, and I think is a good solution here, is the tag. We can add a tag to any view. It's in the all attributes, and it can be anything you like, but in this case, we're just going to have a simple numbering system. So we'll start at 0 and then 1, 2, 3, 4, 5, 6, 7, 8. You could start at 1, but I think I prefer starting at 0 in this case. So you can see here we've just got the tag set there. So it's a little bit laborious, but let's just go through and set the tag for each one. As I say, there are other ways of establishing which image has been tapped, but the tag is very flexible and useful, so worth seeing how it works. Nearly there, so number 7. And last of all, number 8. Excellent. So how do we get the tag then? We can do it simply by looking at counter and then get tag. Simple. So just to make sure that's working, let's do a quick log. We'll get the tag and then we'll just convert it to a string so that we can log it. So now we should see the tag in the logs. And there it is. So that's 0, 8, 7, etc. Excellent. So now we've got the tags, we need a way of keeping track of what you might call the game state. That is, which of these are empty, which of them are yellow, and which are red. So I'm going to use an array for this. And it's going to be an array of integers. I'm going to call it game state. And initially, all of the spaces are, of course, empty. So if 0 represents yellow and 1 represents red, let's use a 2 to represent empty. So initially, our game state is just going to be 9 2s. That's 2, 3, 4, 5, 6, 7, 8, 9. There we go. So let's add that to our codex there. And then when the player drops in a new counter, we just need to update the game state appropriately that we can keep track of each space. So let's first create an integer value for our tapped counter. So we're going to get this from the tag. So again, we'll use counter.getTag.toString, but this time we need it to be an integer. So we'll use integer.parseInt. There we go. And then we just update that with the value of active player. If it's 0, it'll become 0, that is yellow, and 1, it'll become 1, that is red. So we'll set game state tapped counter to be equal to active player. Brilliant. So now we've got an array to track our game state. Really, our final significant step is to establish whether a player has 3 in a row, say along the top, down the side. And there aren't too many possibilities there. It's only the top row, middle row, bottom row, left column, middle column, right column, or the 2 diagonals. Those are the only ways that you can win by getting 3 of those. So the way I'm going to encode this is to create an array of winning positions. So this is going to be an array of arrays. I'll call it winning positions. And hopefully you'll see how it works fairly quickly. So the top winning position is 0, 1, and 2. Those were the numbers or the tags that we gave to those positions. So the first winning position is going to be 0, 1, and 2. The second position is going to be the middle row. So that's 0, 1, 2, 3, 4, 5. So 3, 4, and 5 is our next winning position. And then the bottom row is going to be 6, 7, and 8. If you are following along, you might want to pause the video and see if you can work out what the rest of the winning positions are. But I'll just carry on. So we'll do the vertical ones now. So this is 0, 1, 2, 3, 4, 5, 6. So 0, 3, 6 is a winning position. As is 0, 1, 2, 3, 4, 5, 6, 7. 1, 4, 7. In fact, you might notice that that's the same as the previous one. We've just added 1 to each of them to move them to the right. So we know the last one must be 2, 5, and 8. So those are the vertical winning positions. So the last 2 are just the diagonals. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8. So 0, 4, and 8. And finally, this diagonal is 0, 1, 2, 3, 4, 5, 6. So 2, 4, 6. All right. And then, so when we've brought in the counter, we now want to check against winning positions. So it's going to be reasonably complicated, but stay with me. We're going to need to loop through all of the winning positions and check to see if they've all got the same value, and in the game state that is, and that they're not equal to 2. Because if they're all empty, that doesn't mean that anyone's 1. So we're looking for where each of the winning positions is either a 1 or a 0, and that they're all the same. You might need to take a moment to convince yourself of that. When you have, carry on. So we'll do a loop. So we're looping through winning positions, and each of the values of winning positions is an array of integers, which I'll call winning position. And the thing we want to loop through is winning positions. Hopefully you remember that from section 3. And then for each winning position, we want to check to see if game state, and then we want winning position 0 there. So that's the first value in winning position. And we want to see if the value of that, of the game state of that position, is equal to the value of the next part of the winning position. So we want to see if that's equal to the game state of winning position 1. And we want game state winning position 1 to be equal to game state winning position 2. So if the first one is equal to the second one, and the second one is equal to the third one, then the first one must be equal to the third one. So we don't need to check that separately, but we do need to make sure that none of them are equal to 2, because we want all of them to be either 0s or 1s, i.e. either yellows or reds. So let's just check. Could be any one of them. Let's go for winning position 0 and make sure it's not 2. We don't need to check the other ones because we know that if these two conditions are true, then they're all the same. So if one of them is not 2, then the other ones won't be 2 either. So if these conditions are all met, then the main thing is someone has won. So let's do a quick toast. For now, we'll literally just say someone has won, because I've written quite a lot of code there before we correct this to make it a useful message. We'll just make sure that it is working at all and I haven't made a mistake somewhere in there. So let's let yellows win down the side. Someone has won. Fantastic. Great. So it seems to be detecting that nicely. So let's do a quick check to work out who it is that's won. So we can get that from the active player. Although we do have to be quite careful here, because notice we've already changed the active player ready for the next go. So it's actually the opposite way round than how you'd expect. So if the active player is 1, then the winner is yellow. So let's create a string called winner, which is initially empty. And here we'll set winner equals yellow. Otherwise, winner is red. And then we can just update this to say winner, and then they've won. All right, let's just check that. Make sure that it's detecting the winner correctly, and we'll do a new win this time as well, diagonally. Excellent. So yellow has won. Fantastic. So we've created quite a complex setup there, but it's a neat way of detecting the game state and working out who has won. Now, really could stop there, but it's a little inelegant. There are a few issues going on here, and I'll show you a couple of them. One is, if we tap on space that already has a counter in, it will be replaced by another counter, which is not in the rules. You're not allowed to do that. And another is, we really shouldn't be allowed to continue to play after somebody's won the game. So let's stop both of those things from happening. We'll do them in order. So first off, before we do any of this, we need to check to make sure that the counter that's been tapped on doesn't already have a counter in it. So let's get rid of that log first of all. And let's add a check to see if game state of the tapped counter or space is equal to 2. And if that's the case, then the space is empty, so we can do all of this. But if not, then we essentially want to make that counter inactive. We don't want it to do anything. So we should now be able to play the game as usual, but if we tap on a counter that is already there, nothing will happen. So let's have a look. If I tap on yellow, there we go. Nothing new happens, but I can still add new counters, and I'll just check. Yep, we can correctly detect a red win as well. Great. Now to stop it once somebody has won. So we'll have a Boolean. I'll call it game active, which is initially true. And when someone has won, we'll set game active to be false. And we'll add a check up here. Not only does the game state for the tapped counter have to be 2, but the game has to be active as well. All right, so let's have a look. The game should now finish and cease to be interactive when somebody wins. There we go. So yellow has won, and you see I can't interact with it at all. Fantastic. So we're nearly there. Just one more thing. With the quality of this game, people are going to want to play it again and again. So they don't want to have to close the app down and open it again to start a new game. So let's add the feature to give people the option to start a new game. And I'm just going to put the option at the top here. So we'll have just a small text view. Which will align to the top of the app and center. And actually, I think this is where I'll give the winner rather than the toast so that they can see it permanently. So we'll call it winner text view, and I'll actually move it right up to the top there, making it a little bit bigger. Say 20. And then I'll bring in a button underneath. Not a lot of room, but should just about be able to squeeze them in. There we go. And the button will be centered and aligned to the text view. There we go. And I'll call this play again button. Okay. So just while that's running and we can check that it all looks okay, I'll add an on-click method to the button, which will be play again. Let's have a look. And yep, that looks good. Of course, we don't want it to display initially, so let's set the visibility of each of those to invisible. Excellent. And then we want to bring them in when the winner is detected. So let's find them using their IDs. So we've got first our play again button. We use find view by ID, r.id.play again button. And similarly, the text view is winner text view. This is going to be a text view. Find view by ID, r.id.winner text view. And first off, we want to set the text view text. So we'll take the winner text view and set the text. And we want to set it to the text that we put in the toast before. Let's get rid of our toast as we don't need it anymore. And then we want to set the visibility of both to visible. So play again button. And we haven't done this before, but you might be able to guess. Set visibility to visible. And it gives you the view class, which is necessary for that there in the code predictor. And similarly for winner text view, view.visible. All right, so let's give that a try. We should now find that when we win, instead of the toast, we'll see this play again button, and the winner text view will tell us who has won. Okay, let's go for a diagonal win. Excellent, there we go. So yellow has won, and then button. The button really should say play again. Great. So all that's left is to write our play again method to set everything up so that the game can be played over and over again. So as usual, public void, so won't return anything. Play again, it's called by a view, which will be the button. So let's think, what things do we need to do? First of all, we need to make these invisible again. So I'll do a little bit of copying and pasting there just to save you watching me typing all that again. So we find them by their IDs, and this time we're going to set the visibility to invisible. So that will make the message in the button disappear. We also want to set all of these image views back to empty again. Now that's something we haven't done before, so let's see if we can find a solution on Google. We essentially want to loop through all of the image views, which are all the items inside the grid view, and remove the image source. So let's see if we can find something there. I would search for something like Android loop. Oh, there we go. Look at that. Android loop through all objects in layout. Something like that. Oh, that first one there even includes the grid option for us. Sounds very promising. Let's have a look. So it's a loop through the children, essentially, in the grid view. Yeah, that looks perfect for what we want. So let's copy that over. We will, of course, need to get a variable to link to the grid layout. We've already given it an ID of grid layout. So we can use find view by ID. in the usual way. Resources.id.grid layout, and then we can just replace here with grid layout, and similarly there. Fantastic. Notice though that in this code they're referring to text views. We want to work with image views. And just so that we're reasonably clear on what they are, I'll call them counters. And we definitely want to cast that as an image view. Notice this is a different method to the one up here. So I can use the variable counter again, and it won't conflict because the scope of the variable is just inside the method. It doesn't exist outside that method. All right, now we need to take our image view and remove the source from it, which is another thing we haven't done. So let's take a look. Android, Java, remove image view source. Remove the image from an image view. That looks pretty perfect. Okay, image view, and then set image drawable to null. Makes a lot of sense. Let's give it a go. So counter, set image drawable to null. Great. Is that everything? Our UI should look good now because we've reset all of these and we've removed that. But our game state variables won't be correct. So we'll just need to change most of these back to their defaults. The only one we won't need to change is winning positions because that's fixed. That doesn't change anyway. So we want to change the game state back to a bunch of 2s, an empty board. The active player is yellow again, and game active is once again true. All right, fingers crossed. We did change a lot of things there and add quite a lot of code, so it could be a mistake. But let's give it a shot and hope that everything works as desired. Okay, so first of all, let's get a red win. Try out this diagonal. Excellent, so red has won, play again. All looks pretty promising. Aha, but nothing happens. That's because, you can see what I've done here. I've actually created these variables once again inside the method. I don't want to create them, I want to update them. There we go. I thought that was worth leaving in, that particular error, because it's an easy one to make, and it brings to light another issue that we can't simply update all of the values of an array in this way. We'll have to do that using a loop. You see we've got an error here. We're not allowed to update an array in the same way that we define it. So let's just loop through all of the items in game state. So we're going to go up to game state dot length, incrementing each time, and we just want to set game state I to 2. All right. So let's try again. With any luck, that will now work as we need it to. Here goes. So again, we'll do a red win. Oh, no. Can't help it. A yellow has won. Doesn't matter. Let's play again. And now it's looking good. Let's give red the win they should have had before. Red has won. Wonderful. Great stuff. So that was quite a complex game, but hopefully you managed to figure most of that out yourself and at least managed to follow along and see what we did here, particularly with the winning positions to work out the game state and whether anyone has won. Wonderful. So I hope you enjoyed that. Now let's move on to the other two main topics of this section, audio and video.